Hey guys, welcome back. Today we're going to take a look at something that I get asked all the time, and it's how can I add C++ to my project? And so we're going to take a look at how we can do that, and we're going to build our first custom blueprint node in C++. Okay, as I explained in the last video, the project will be provided. So here it is. The last project was 39. We're now on 40. I'm going to double check these when you look at this because I'm going to actually flip them so that the newest is at the top. So be careful and make sure you click on the download below the one you want. So I've downloaded it and I've followed all these instructions and I now have this right here. Okay, and so the first thing we want to do is that we do not have a Visual Studio solution. So what we're going to do, I'm going to right click on the U project file. We're going to say generate Visual Studio project files. Now I'm using Visual Studio 2017. This is generating a project for Visual Studio 2017. Whether 2019 will work or not, I have no idea. You will need Visual Studio to continue with this video. And the rest of the series too, so go get it. Starting in 4.25, which will hopefully be very soon, we'll actually be switching from 2017 to 2019. And starting in 4.25, the solution that's generated is a 2019 solution instead of a 2017 solution. It actually fails to compile with 2017. I'm sure there's a way to make it work, but it doesn't work by default. Okay, so I'm going to open that up. Be sure when you install Visual Studio 2017, the default installation actually does not work. You got to go through and you got to make sure you enable C++. You got to make sure you enable a few of the other things. I think the Windows Platform SDK. There's a couple others. And surprisingly, there's a line that says Unreal Engine. You don't want to enable that. You actually want to disable that because you already have the launcher, and that just installs the Unreal Engine launcher. Okay, let's take a look at our project here real quick and talk about a few things in Visual Studio. So the project that it creates here has the engine connected to it, okay? And that's not the full source engine. It's just some header files and stuff so that you can look into it and see what's going on, but you can't step into it unless you have the full source engine. Then we've got our project, Open World Starter. We're going to right click on it here and say set as startup project. It may have already been. Under plugins here, you see the OWS plugin. You don't need to mess with that. You've got your config files here. And then we've got our source. Here are our targets. So let's go take a look over here at targets. So this box here, solution configuration, has our targets. The ones you're interested in at this point are development editor. This is the one that runs when you double click a U project file. And then debug game editor. This is the one you need to run if you want to step through your code in Visual Studio. Development editor is optimized. Debug game editor is unoptimized. When you optimize code, you can't step through it anymore because what ends up happening is the code you write gets removed and replaced with code they think is better. That Visual Studio thinks is better, so therefore it can't step through your code. So debug game editor is the unoptimized, which is what you would need to do if you wanted to step through it. We're going to stick with development editor for now. But there's also development server, which would end up using this server target here. But that's a whole different thing. We'll get into that later, how to finally build the server. Make sure it's on development editor. It's got to be Win64. Okay, so we got this MyEngine subsystem here. This is something that in 4.2.4 had to get added for gameplay abilities. You can ignore it for now. These main H file and CPP files that match your project, we can ignore those. We're going to take a look at this build, though, because this is important. We will be having to edit this to get this to work soon. But it basically has public dependency module names, which means stuff that other modules after this can inherit. Well, there really aren't. Your game's the last module. There's nothing that's going to inherit the module from your game. Private dependency modules, which means only available to this project. And then public include path module names. Include path for H files. Okay, so what we're going to do here to begin with is that we want to compile this. So we're going to hit the play button, and it's probably, let's see what happens here. It's going to compile it. Okay, cool. So I provide binaries along with the project, which is why you can double-click on the U project, and it often just loads up. However, if you got a slightly different environment configuration operating system, it may not, in which case it would be redoing this, which is compiling it for your environment. It shouldn't take too long. It's compiled our project. Now it's compiling the OWS plugin. Then it's going to start up. So this is actually how I run all my projects. I never double-click on a U project file, ever, for any reason. I always open Visual Studio, make sure I'm on the right solution configuration here, and then press play. That's how I always run it. One of the pluses to that system is that a lot of times when UE4 crashes and you lose your work, if you're running from Visual Studio, it actually will pop up an error message in Visual Studio and say continue. And about 90% of the time when you hit continue, it'll take you right back to the editor where you were and you can continue and not lose your work, which is really nice. So that's one of the main reasons that I do it. But it also allows me to drop a breakpoint in code anytime I want to better troubleshoot and debug. You will find that in multiplayer games, blueprint debugging just isn't a viable thing. This print string stuff is nonsense. It's just not very viable. And so you will find that debugging and troubleshooting in C++ is significantly simpler and more efficient, and you will be able to do it quicker. So that's another reason that I always run from Visual Studio. Okay, so what we're going to do, we said we're going to create a blueprint node. So I looked all around the code, and I was like, you know, what's a good thing? And it was actually harder than I thought to find. Our blueprints weren't that ugly. The skill tree stuff was, but I didn't want to mess with that. So I ended up finding that in this rbase character, there were some calculations being done in the foot IK. Now, normally I would just rewrite this whole thing in C++, but I said we're going to create a blueprint node. So what we're actually going to do is we're going to replace this. So what I've just highlighted there, we're going to make it one blueprint node. And if you look at this code, you can see that it's calculating. It's taking the start and end vectors, and it's using those with this hit location from this line trace, and it's calculating a foot offset and a pelvis offset. So we are going to create a blueprint node, one blueprint node that does everything that I've just selected. Okay? So I've already taken a screenshot of it here, which we're going to be using. Although you can write C++ code while the editor's open, so we could do that too, but I just took a screenshot. One thing I did want to take a look at real quick, because I made this little graphic, is just to give you a quick idea of how C++ works here and what's happening. So Unreal Engine is our lowest layer here. And below that, you've got like DirectX, and you've got other Windows stuff and other operating system things it's calling. Your C++ project code sits on top of that, and you're making calls to Unreal Engine C++ code. But then your project blueprints sit on top of that C++. So your project blueprints can make calls to C++ in the project. They can make calls to C++ in the engine. Every one of these BP nodes that you're looking at is C++ in the engine that it's calling, unless it's a macro, but then those macro things in the macro end up calling. For the most part, though, you can't get Unreal Engine C++ to call your C++. You can't get your C++ to call call back to your blueprints and stuff. There are a few limited ways, but ideally you generally go down. Often the way that you do this, which is what we're going to do here right now, is that we are going to inherit from something. So Unreal Engine C++ has something called a character. It's a character, and they put A in front of it because it's an actor. Then in our project, we have the OWS plugin, which has this OWS character with abilities, which inherits through a few other ones, ends up inheriting from a character. So we've got a OWS character with abilities. Now we're going to add another one that right now our base character inherits from OWS character with abilities. We're going to add another one that basically inherits. We're putting something in between. So what we're going to do is we're going to go do that. So I create my C++ code here by doing new C++ class, show all classes, OWS character with abilities. I'm going to call this, let's make an MMO character long names are bad. They end up leading to trouble. Try to keep it as short as possible. You can put it in the OWS plugin or in the OWS World Starter module. We're going to put it in the Project Starter module. And you can choose whether it's public or private. Public would mean modules that use this module could use the code, but there's nothing. This is the game. It's the end of the line. It's the last piece. So we're going to create a class. And it's going to fail. It always does. But it's fine. Just telling us, hey, you're going to have to reload to do that. There are some things, there's this compile button up here. You will find there are some things that you can compile while staying in the editor, and there are some you are not. Often you just get tired of things not working, and you just do it the long way. Okay, so we're going to close this. And we're going to come and see that it created this private folder. And it created a header file and a C++ file. So you can see there's not much in them. This here is the header file. Here's what we're including. This is our class. This is what we're inheriting from. Generated body, don't mess with it. Code gets inserted there that Unreal Engine needs, so we start below it. Do public. Blueprint nodes have to be either public or protected. They cannot be private. And we are going to, so the way that this works is that we declare things in the H file and we define them in the C++. So declaring them just says, hey, we have this thing. And then defining them says, okay, here's what that thing does. And so we're going to go and define something. But we first need to tell UE4, this is a UE4 macro that it's actually not a C++ macro, it's a Unreal header tool macro. We're going to do blueprint callable. And we're going to put it in a category. These are all just directives to blueprints to tell it what to do. It's going to end up in the foot IK category. Okay, so we need to actually return two values. Let's get our screenshot. So we need two output values, foot offset and pelvis offset. Well, C++ by default only returns one, or only supports one output. So we're actually not going to use their output system of the function, and we're going to say void. We don't want to return anything. Calculate foot and pelvis. It's good to name things descriptively as to what they do. Offsets. Calculate foot and pelvis offsets. Okay. Now, we got to look at the things we're going to send to it. So this red line over here actually comes from blocking hit, but it's over there. So we're going to do that first. And it was red, so it's a bool. So we're going to do bool be blocking hit. Okay, if we take a look at what's next, these yellow lines were actually the trace start and the trace end, and they're actually reversed. So this one is the trace start, and this one is the trace end. I got those mixed up when I was doing it earlier, so we got to make sure we don't do that. And they are vectors. So we're going to do f vector, trace start, f vector, trace end. And then we need this hit location. See, it's a hit location. So we'll do f vector hit location. And there's a float we need. So normally I would make this a variable in C++. Another rule I have is never create variables in Blueprint, because trying to swap them out later if you want to move them to C++ is a real pain. But in this case, it's in Blueprint, therefore we need to send it in. So float max foot trace distance. Max foot trace distance. Okay, now we need to have the outputs. Okay, so the outputs were foot offset and pelvis offset. So we're going to do float, foot, offset, float, pelvis, offset. Okay, but this is not going to work. The reason why is because it's going to think these are inputs, and they're not. They're outputs. So what we have to do is we have to pass them by reference. So what's happening here is that these values are being passed by value. The value is being copied and sent in. These two are being passed by reference, which meaning it is not sending us the value of foot offset or the value of pelvis offset. It is sending us the memory location of foot offset and the memory location of pelvis offset. UE4 knows that since you sent the memory location like that, it will make them outputs on your blueprint node, unless we did const, which basically means they're constant and you can't change them. So if we were to do this, foot offset and pelvis offset would be inputs, but because we listed them as non-constant, it knows to make them outputs. We're going to copy that. I didn't copy the semicolon. We're going to come over here. We're going to do our start and end braces. Okay, this is not going to work. And the reason this is not going to work is because just because you put it in character CPP, the code doesn't go in character CPP. The files don't mean anything. You could, if you wanted to, I don't recommend this, you could start mixing up and just putting stuff anywhere in any file. It doesn't even matter. Don't do that because organization is good, but C++ doesn't care. So we have to tell calculate foot and pelvis offset that it is part of a LM, a MMO character. And we do that using what is called scope operator. So that now tells it, hey, I want you to put calculate foot and pelvis offset in this. Now if we did this properly, we will be able to hit play, and this is not going to work, but I want to show you before we get into more what you got to do here. The reason it's not going to work is because we're inheriting from OWS character. Okay, first thing here, this air list, like, you don't want it. Just hide it. It's annoying. It doesn't mean anything. It's bogus. Instead, you want to read through the output. And the output says, cannot open include file JSON object wrapper. Oh, JSON. Interesting. You're like, but I didn't use JSON. You didn't, but I used it in OWS character with abilities, and your build doesn't have it. So what you want to do is you want to go into here into plugins, OWS plugin source, and we're going to go to that build, and you'll see here that it has JSON and JSON utilities. I don't know which one we need. I'm going to grab both. I also don't like it that way. I like it styled this way. I think it's easier to read. Okay, we're going to do that, and that's not going to be enough, but we're going to do that. And you're going to get a different error. Now this one says, oh, well, that's just that I made a typo. It's going to give us a new error. Okay, so, we got some linking errors. So it's telling us generic team agent interface. We're like, what is generic team agent interface? So we're going to go copy that. I'm going to bring up Google. I'm going to search for generic team agent interface, and I get this page. So what we do is we scroll down here, and we see that it is in AI module. So we copy that, come back here, and we add AI module. And we hit play. There we go. So we've now added the missing JSON utilities and AI module that we need because we were inheriting from OWS character with abilities. Now over time, if we use things that are in different modules, we'll have to add them there. And you can always check the UE4 C++ documentation. I guess I don't need to do that. I'm so used to just loading those. All I wanted to show here is that we can now go into the foot IK, and we do calculate. I know this isn't going to work, so I'm doing this on purpose. Oh, it's not in the list. What's wrong? Look at the parent. We didn't reparent it. So we need to go and reparent it. Now you got to be careful with this one, because if you do this wrong and pick the wrong one, you may potentially completely destroy this blueprint, which could completely destroy the project. So we make sure, we're very careful that that is for sure what we want to do. We select it. It changes the parent class up here. And now we start typing calculate, and look, it's under the foot IK as we wanted it, under that category, and we have our node. We look at it and see that it does correctly have those outputs that we're going to drag here, and it correctly has the inputs. We're actually going to, is a different order than I did before, but I'm going to actually hook them up. So what we're going to do is we're going to leave all this code in place so we can compare back and forth just in case we do something wrong. I'm just going to leave this up above and hook these up. There's the blocking hit. Remember, the top one is the start. The bottom one is the end. The hit location comes from here. And I'm going to copy this right underneath it. And then, of course, we need to move our execution pin. Okay. We don't want to run this, though, because this does nothing. In fact, it actually will probably crash or throw some errors because we're actually not returning the values we said we would return. This is probably okay, but yeah, anyway, it's not. I think that this will initialize them to 0 and they'll just be zeros, but that's not what we want to do. So now we want to go and write our function. So what I like to do is, knowing that these are what I want to output, I'm going to put them at the end and just set them to 0. So we remember, this is where we're trying. That's weird. If you double click on a word, you can get it to select it. Okay, that's what we're trying to end up with. Okay, so what I do is I'll usually work from this direction over to here, or I'll work from the lowest component up. And so I'll try to find some components that are duplicated. And you can see right away that getting this capsule half height and getting this capsule half height here, it's kind of used in two places. So let's create a temporary variable to hold those. So we'll call it float capsule half height equals. We're going to do get capsule component. Often the names are the same, sometimes they're not, and I'll talk about that in a second there. Get scaled capsule half height. So that's basically going to be this. We got the capsule component and we did this. Now this here, because the capsule component returned a U capsule component pointer, see the star? We had to use the pointer operator instead of the dot operator. So we're going to use the pointer operator, which is a dash and a greater than. Okay, now when we compile this, it's actually going to fail. Okay. It keeps bringing this error list back. Okay, it says use of undefined type U capsule component. Oh, it doesn't know what that is. We need to tell it what it is. So we go back to our UE4 documentation and we do UE4 C++ U capsule component. And remember how it had the module? Well, it also has the include. So copy that include. Come up here. We always leave this one as the bottom line, the last one. And now, let me hit compile. It should be happy. It is. I'm going to hit stop because I don't want to continue loading it. Cool. So we now have this value and this value. Okay. So the next thing that we kind of see here is that this starting value, this starting trace, actually this is the start trace, this is the end trace. They're being the hit location is being subtracted from them both, and then we're getting a vector length. Okay, so we kind of want to get those values. So I'm going to do this a little different, just to show you that there are many ways to do the same thing. I'm going to create trace start minus hit location vector length. Copy and paste and change the word to end. So up here, we declared and defined all in one line. Now we're going to do it in separate lines. So this trace start hit location vector length, remember this is the bottom one. It's this one. We subtract the hit location and then we get the vector length. So we're going to set that equal to trace start minus, and we called it hit location that we sent in. And we try to do vector length, and there's no such thing. This is a tough one here. You have to just know that this one's actually called size. So if you went to the vector documentation and you scrolled through it, maybe even if you search for vector length, it might return you size and you would know that it's size. This is some of what makes UE4 C++ programming interesting, is that sometimes they're not named the same thing and you got to go looking for it. But basically this vector length here is size. Okay, so now we're going to do trace. I don't like typing. And we're going to do the same thing on this one, but with the trace in it. So we now have basically this output point and this output point. So this was the start one, and this is the end one. So now we take the start one here, and we subtract that capsule half height, multiply it by 1, and return the output. Now the select float is saying if it's a blocking hit, return the value. If not, return 0. Well, that's called an inline or immediate if. So we're actually going to come here, and that's for the pelvis offset. So we're going to come down here on the pelvis offset. We're going to replace this with the structure. Okay, so the way that this works is it says if the value before the question mark is true, do this. If the value before the question mark is false, do this. Okay, so we obviously already know that the false is going to be 0.f. Okay, and B blocking hit is our value to test. So now we only have to write this. And so what we said is that we would take that trace start minus hit location vector length, and we would subtract this capsule half height. But if you remember, that wasn't enough. Putting parentheses around it because of order of operations. We want it to do the multiplication we want it to do the subtraction before it does the multiplication. Normally it would do the multiplication first. So we have to times it by -1. So we will do outside the parentheses. We will do the multiplication symbol. Not 0.1. 1 point f. There we go. That'll multiply it by 1. The point f is just saying that it's a float constant. Okay, so the next one we want to do is the foot offset. And the problem with that one is we need this max foot trace distance subtracted by the capsule half height. So we're going to create another intermediate float max foot trace distance minus capsule height equals. And we want to take that value we sent in and subtract the capsule half height. Okay, so we now have that stored here, and that is basically this value, right? Max foot trace distance minus this, so it's here to go into this. So now we'll subtract that value from the end. So we're going to create that same immediate if structure. And the false is 0.f. I'm going to put this here. And that is being subtracted. Let's see. Yeah, we're subtracting this other temporary value, max foot trace distance minus capsule height, from that. And we're using B blocking hit. So that should be the entire calculation. So those select floats at the end based on the B blocking hit are these inline if statements. And I think we're good. So let's compile it. We will test it out. That's the only way to know for sure. And then we'll talk about the performance issue. Maybe as you were looking at this, you already realized that what we wrote wasn't the best performance-wise. So we'll talk about that. So I believe that we already hooked this up. We did. We left this down here in case we need to test it, but we hooked it all up, so we should be able to run it. We will make sure that Run Dedicated Server is checked. That will not be done on a new project. Always starts unchecked. Okay, then we're going to hit play. Watch it be nighttime. It's always nighttime. No, not too bad. Okay. So our feet are on the ground. That is a good sign. If you do it wrong, your feet may be up in the air. I only did it wrong twice. But really what we're looking for is to see if on these stairs, look at that. It's working as intended. So what we basically did here is that we now replaced all of this ugliness, which we're now going to delete. And this. No, we need the location from it. We're going to delete all that ugliness. And now we just have this nice blueprint node. Make this more compact. We have this nice blueprint node doing all that functionality for us. See if this works. It does. Cool. So you can actually get it to go to the code directly by clicking on it. Another thing that I didn't show that I wanted to show is that you can actually also, remember how we talked about definitions and declarations? You can come to the declaration and say go to definition, and it'll take you to the code as well. That one's useful when you end up with tons and tons of code. So now you have built your first blueprint node in C++, and you can use this to replace anything that's complicated that you want to turn into a blueprint node, you know, and make things simpler. It really can clean up your blueprints. In the future, we'll talk about what I would have actually done, which is just replace this entire footIK function. We'll talk about some of the other ways that you can move things to C++, but I wanted to look at custom blueprint nodes first. And so that is going to wrap up this episode. And until next time, see ya.